Hello everyone, welcome back to my YouTube channel. So today I'm going to discuss a question from chapter Oscillation that I have taken from a Pathfinder. Let's read the question first. A particle of mass m can move along x-axis of a coordinate frame in a force field of stationary sources. Potential energy U of system varies with position x, the particle according to equation. So there is a mass m which is present in a force field of a stationary source, and potential energy of the system varies according to this equation U equals to k times mod x, where k is a positive constant and the particle is projected from the origin with a kinetic energy k. Find period of its bound motion. Okay. So it's given in the question this particle of mass m is present in the force field of a stationary source, and the potential energy U of system varies according to equation U equals to k times mod x. And this particle is projected from origin with a kinetic energy k, so I have to find the period of its motion. Okay, let's analyze the situation. If you see, a potential energy of the particle is U equals to k times mod x. If I remove this mod x, this can be written as U equals to k times x, right? If x is greater than 0, that means my potential energy of the particle in positive x-axis is kx, and U equals to k times minus x if my x value is less than 0, if I remove this mod value. So I can say that in positive x-axis my potential energy value will be varying according to this equation, and my potential energy in negative x-axis will be deal with this equation, right? Okay, from this I can derive a force value, right? Because I know that my force value is equal to minus du upon dx, right? Since I have two potential energy equation, so I'll be getting two forces based on if my particle is in positive x-axis or in negative x-axis, right? So I can write F is equal to minus d of dx of kx if my x is greater than 0. That means f value is coming to be minus k if my x is greater than 0. This is my equation 1. Similarly, f is equal to minus d of dx of minus kx if my x value is less than 0. So my f value is coming to be k if my x is less than 0, right? So with this I am having two force equation. F is equal to minus k if my x is greater than 0, and F is equal to k if my x is less than 0, right? That simply means that if my particle is in positive x, there will be a force which is directed towards negative direction like this, and if my particle is in negative x-axis, then the force direction will be towards positive direction, right? That I can infer from the that I can infer from the equation that I got. Okay, so I got the relation for a force. Now it's being said in the question this particle is projected with kinetic energy k. So that means this particle is initially projected with some velocity, right? So let's say this particle is projected with some initial velocity. It is projected with some initial velocity u, right? So u value I can easily find because my kinetic energy k is given to be half mu square. So my u value is square root of 2 times k upon m. Okay, I got this initial velocity. Now if you see the direction of the motion of the particle in the first case when the particle is projected, towards positive x-axis, the direction of motion is towards right, but the force is acting towards left, right? So this force will be causing a deceleration in the body. So finally, what will happen? This mass will cover some displacement, right? This mass will cover some distance, and finally, this particle will come to rest, right? Because force is in opposite direction to the direction of motion, right? So here my final velocity will be 0. Now, when the particle will be having a velocity 0, still my force is acting towards left. So my force will start dominating, and because of this force, the particle will again start moving towards left, right? So finally, after coming to rest, the particle will again move towards origin like this, right? When it will move back to the origin, the particle will gain some velocity here, right? And because of this velocity, the particle will move towards negative x-axis like this, right? But when the particle will come in the negative x-axis, the force direction is towards right. So again, the particle will go into deceleration, right? And finally, the particle will again come to the rest here. Here it's rest, here it's in motion, and again it's rest. Now what will happen? Again, this force will start dominating, and this force will make the particle move towards left like this, right? So you can see that this particle is oscillating within a certain range, right? And it is symmetric about y-axis, right? I cannot say that this particle is doing a SHM, because if you see my force value, both the cases, these values are constant, right? So this is not having a SHM, right? Because for SHM, my force has to be proportional to displacement, right? But it is not happening, so I cannot say this motion is a SHM motion, but this particle is obviously having a oscillation motion, right? And it is symmetric about y-axis. Okay, so if I find, let's say if I find the time taken by the particle going from origin to rest, right? And if I multiply that with 4, I can get the time period because it is symmetric about y-axis, right? So the time taken by the particle to go from 1 to 2, position 1 to 2, let's call this, and again from position 2 to 1, right? The time taken by particle to go from 1 to 2 will be equal to time taken by particle to come from 2 to 1, right? And the time taken by particle to go from 1 to 3 will be again be equal to time taken by the particle to go from 3 to 1, right? And it is symmetric by y-axis. So if I find the time taken by particle to go from 1 to 2 and I multiply that with 4, I'll get the time period of this oscillation, right? Right? So let's find the time taken by the particle to go from 1 to 2, right? So if you see, initially the particle was projected with velocity u, final velocity is 0, right? And I have a force equation, so I can find the acceleration and I can use equation of motion. So I know equation of motion, v equals to u plus at, right? Final velocity in case of 1 to 2, if you see, 0. Initial velocity I got, that's root under 2k upon m, plus acceleration. If you see, my force value in positive x-axis, it's minus k, so my acceleration will be what, minus k upon m times t. So here if you see this K this is my small k, okay? Be careful about this. And this capital K is my kinetic energy, okay? So this can be written as small k upon m times t equals to square root of 2 times capital K upon m, right? So my t value is equal to small m times 2 times square root of k upon m upon small k. So this t, small t value can be written as square root of 2 times capital K into m upon 1 upon small k. So my time period for bound motion is equal to 4 times small t, and that is equal to 4 upon small k square root of 2 times capital K upon times small m. This k was my positive constant, and this k, capital K, is my kinetic energy.